Now let's look at our linear applications with distance. Some Algebra 1 type of distance problems. A driver averaged 41 miles per hour and took 6 hours to travel between two cities. What is the distance between the two cities? Well, our distance formula is as so. D equals RT. The distance I traveled equals the rate. In this case, in America, we use miles per hour. Other countries, kilometers per hour, times time. So how fast I was going times how long I was traveling. That's my distance. So as I look at this problem, the driver averaged 41 miles per hour. That's my rate. So R equals 41. And took 6 hours to travel between the two cities. 6 hours, T, is my time. So to find my distance, my rate times my time equals 246 miles. So perhaps there was traffic or a lot of speed traps. 246 miles, took him 6 hours to get there. Average rate of 41 miles per hour. Now you give it a shot. You're visiting your grandmother who lives 540 miles away. If you took 6 hours to get there, what is your average speed? So trying to find your average speed using D equals RT. Alright, so I'm looking for distance. Do I know the distance it took me to get to grandma's house?
Yes.
540, right? Equals R. Do I know how fast I was going? No. So we'll just leave that as R. Times T. Do I know how long it took me to go to grandma's house?
6 hours.
6 hours. So 540 equals 6R. To find R,
Divide by 6.
divide by 6 on both sides. And I get R equals 90 miles per hour. Somebody is really excited to go to grandma's house. Let's look at this one. Traveling to work takes 30 minutes by car and 18 minutes by train. How far is work when the train averages 20 miles per hour faster than the car? Like I said, like the problems yesterday, it's imperative you start with a table. So our table, we know our formula is distance, rate, and time. So the distance. Do I know how far the car was traveling? No. I start here and I go to work X. No. So I'm just going to call that D. The train started the same spot and traveled and ended at the same location again, at work. So if my distance traveled for my car is D, what's the distance for my train? The same. They both traveled the same distance. So I'm going to call them both D. I don't know what that distance is, but I do know that they took the same route. They started at the same place and ended at the same place. How about that? Rate, do I know how fast each of these were going? How fast was the car traveling? I don't know, do I?
No.
So I'm going to call that X. And if my car travels at X miles an hour, how fast was the train traveling? Very good. It is 20 miles per hour faster than the car. So plus 20. Some have said times 20x, 20 times x. You wouldn't say that unless you see the train averages 20 times faster than the car. Something like that would be up here. It just says it's 20 miles an hour faster. So you do addition. And then the time. Do I know how long it took the car to get to work? 30 minutes. Now, we travel in miles per what? Hour. So I need to convert this to hours. So unfortunately, if you see minutes, you'll always have to convert that to hours. So 30 minutes and 60 minutes in an hour equals what? 1/2. So it's actually 0.5 hours, just to keep with our rate that's measured in hours. And then the train took 18 minutes, so 18 divided by 60 is 0.3. The train took a 1.3 of an hour. So here's our table, all nicely neat and filled out. Anybody have any questions on how we got any of these values inside this table, especially with the conversions? Again, we're talking about miles per hour, so we have to do our time in terms of hours. All right, now that we have our table, it gives us equations, because I know my formula is D equals rate times time. So my first equation is D equals 0.5x. That's my first. D equals 0.5x. I have another one where I have D equals x plus 20 times 0.3. So that is my second equation. D equals 0.3 times x plus 20. So each of these rows gives me a separate equation. Now let's look at these two equations. What do you notice about these two equations that they have in common? They both equal D. So if your equations equal the same variable, then you can set the two equations equal to one another. So I have D equals 0.5x. So let me substitute or replace this D with that 0.5x. I can set the two equations equal since we're both going to the same spot. My rate times my time on my car will equal my rate times my time traveled with the train. Just note that the train is a little bit faster. So now that we have 0.5x equals 0.3 times x plus 20, note that there's just one variable. I can now solve for that one variable. So I'll have to distribute this 0.3 to x. That's 0.3x. And then 0.3 to 20. 0.3 times 20 is 6. Once you're here, what would you want to do next? Yeah, get one variable. So subtract 0.3x to both sides. That'll cancel that. 0.5 minus 0.3 is a 0.2x equals 6. And then last but not least, let me get x by itself. So divide by 0.2. 6 divided by 0.2 gives me 30. In this case, my x is my rate. So 30 miles an hour for the car. So whenever you get your x, go back to your table. What was your x in that table? My x was my rate of my car. Was that what the problem was asking? No, it's asking what? How far. So how can I take x equals 30 and find out how far work was? Yeah, plug it in, right? Plug it in for x. So look at my car, D equals 0.5x. I now found x to be 30 miles an hour, so let me plug that in. 0.5 times 30. My work was 15 miles away. So let's see. Anything else I want to mention? So that's how this is going to work. You're going to have two equations that's going to give you based on the D equals RT. And you'll want to do your best you can and set those two equations equal to each other. Make sure they are equal to D. Let's look at another one. Two high-speed ferries leave at the same time from a city to go to the same island. The first ferry, the Cat, travels at 30 miles per hour. The second ferry, the Bird, travels at 25 miles per hour. In how many hours will the two ferries be 5 miles apart? Only way to solve this is to do a table. Now for me, it helps drawing pictures in order to put values in the table. So I have this cat. I know it's traveling how fast? 30 miles an hour. So for the cat, the rate, I want to put 30 miles an hour. Then I have the bird. It's traveling a little bit slower at the speed of 25 miles an hour. So for the rate, I'm going to put 25 miles an hour. Now, these things are traveling at the same time, right? I say go, and they're all moving at the same time. One's moving a little bit faster than the other. And right when the bird is 5 miles behind the cat, I want to say stop. I want to stop that moment in time. So here's my moment in time, where the bird is 5 miles an hour behind the cat. If I'm calling the distance of the cat d, what is the distance of the bird at this moment in time?
D minus 5.
Very good. It's going to be d minus 5. If I'm calling this moment in time for the bird t, what's my moment in time for the, sorry I said bird, I meant cat. What is my moment in time for the bird? It's the same. T. Remember, it's the same moment in time. Stop.
Oh.
They're right here on this moment in time. They're using the same amount of time. I just don't know what that is, so I'm going to call it them both T. So here's my chart filled out. D, 30, T. D minus 5, because at this moment of the same time, it's 5 miles behind, and it's going at 25 miles an hour. The next slide. There we go. Now that I have my table set up, which is always the hard part, I can make my two equations. So using my formula D equals RT, my first one is D equals 30T. The second one, D equals RT, so D, in this case D minus 5, equals 25T. Now what's the difference between these two equations from the previous problem? Yeah, it's not equal to D. So what can I do to set it them the same? Yeah, just add 5 to both sides. Plus 5. Now I have these two equations, D equals 30T and D equals 25T plus 5. Now that they're equal, I can set them equal to one another. Note that there's actually two ways you could have done this. You could have taken this and substituted 30T for D, like was done here, and then solve for T. Or really what I like to do, my preference, is to set them both equal to D, and then take those two and set them equal to one another. So I have 30T equals 25T plus 5, then solve for T. Minus 25 on both sides, that'll cancel. 5T equals 5, divide by 5 on both sides, T equals 1. So how long did it take for the fairies to be 5 miles apart? 1 hour. I want to go ahead and talk about linear applications writing equations. First, let me go over some translations. In English, if you see is, that's the same as the equal sign in math. If you hear the word sum or more than, that's going to be addition. Difference, less than, think subtraction. If you see the word product, multiplication. And there's two ways it's going to set up. If you see it set up as a number, comma x, well then it tells you what that number is. That number is x. But if it doesn't, if it just says a number and doesn't give you any variable associated with that number, then it translates to parentheses. So if I have a number and I'm adding it to a second number, with that second number is an x, what I mean is I have a number, I am adding it to a second number where that second number is x. It should look like this. Because it didn't tell me what this number was. Let's assume that it's some kind of parentheses, something's going on inside of here. So let's look at an example. Let's see if you can write this out. A number is 5 less than 9 times a second number. Their sum is 63. If x represents the second number, write an equation to find the two numbers. So I'm not asking you to solve. I want you to go ahead and try to write the equation of these two numbers. So go ahead on your table, see if you can come up with the expression. If anybody gets it, I'll give you a token. Oh, you're close. Very close. luckily, on the TEACS test, this will be a multiple choice form. On the test on Friday, this will be a multiple choice form. So you at least get to see your options and see if they match up to what you see in the English. Might make this a little bit easier. Although I say that, the one they did last year only had like a 5% success rate across the entire district. Okay, let's look. So a number, does it tell me any kind of variable that represents that number? So I'm going to write parentheses. Is 5 less than 9 times a second number? Okay, so there's something going on here. There's some, so I have a number, I have a second number. Does it tell me what that second number is represented as? X. So I have a number where there's a number and a second number. There's some. So I'm doing what? Is 63. So a number where it's sum, or a number and another number's sum is 63. Now what goes on inside of here? A number is 5 less than, so what does that mean? Some kind of minus 5 going on here. 9 times a second number. What's my second number? X. 9 times the second number. That's how it's written. So let's follow the colors. A number, parentheses. First thing you should write is 5 less than. So inside here, minus 5. 9 times a second number. Well, I had to read later on to figure out that second number was x. So 9 times x. There's sum, so the first number and the second number sum is 63. Again, follow what your expression is carefully, because like I said, it's going to be multiple choice to the actual English, and make sure it all, no pun intended, adds up. So when you see 5 less than, you should expect a minus 5, right? Not a plus 5. You see there's sum is 63, you should see a plus, not a minus. Does that make sense? Make sure everything's there that it says. This one's a little bit easier. Maybe you'll have more success on this one. A number is 4 more than a second number. Their difference is 11. If x is the second number, write an equation to find the two numbers. So a number, parentheses, is 4 more than the second number. We find out that the second number is x. So this number is 4 more than x. So x plus 4. Their difference, so that first number and the second number is being subtracted, is 11. Should have gotten this. Now, there's another way you can work this out. The correct way is to write out the math exactly how it reads off. So a number, we'll say y, is means what? Equals 4 more than the second number. So my second number is x. Where do I put the plus 4? Well, what side of it is on the is? Right here, right? A number is 4 more than the second number. You could have written as 4 plus x. That's fine. Period. Equation's done. The next one says their difference, so y minus x, their difference, y minus x, is, which means equals, 11. Now, how do you put it together under one variable? Substitution. So I'm going to substitute this in for y. And do I not get x plus 4 minus x equals 11. We can look at the previous problem, just like that. This is one, yeah. A number, so let's say y, is equals 5 less than 9 times the second number. So 9 times x. There's my first equation, period. That equation is done. The sentence is done. Next, their sum, so y plus x, we're adding them together, is equals 63. Again, how do you put these two together? Substitution. Replace that in for y, and you get it. Same thing. Each sentence usually is followed by an equation, and you can usually write it out exactly how it's worded in English. So that's one way of doing it. I didn't want to start off like this, but if that helps, then go ahead and do that. Just because this way is, your multiple choice is going to already be in this format and not in this format. But if you're doing freehand, I would kind of maybe do it like this.